All right, so Newton's third law states that for every action there's an equal and opposite reaction. So here we have these 5 different spheres. They're all the same mass, and they are suspended from kind of like a little fishing line is what it feels like. Has anybody ever played or used one of these? Good. All right. And I will leave it up here. You're welcome to kind of do some like experimenting on your own. Just be careful because I do not want the, like if you have to be easy because you don't want them to like get all tangled up and crossed up and it can cause a big mess. So if you're gonna do it, like that's fine. Like, you know, I encourage you to do, you know, to try some different things. But just be easy, like don't be crazy and like do it from up here and then it falls and then it gets all tangled. So just be easy. If you would come up and try it, okay? So Newton's third law says that for every action there's an equal and opposite reaction. We said that the mass had a big influence on how things are going to behave, right? So sometimes if there's a really large mass, then it's not going to really feel the effect and we're not going to see that reaction force as much as we would. But if things are the same mass, then like the one video showed yesterday, you would expect that everything should respond equally. So if I raise this sphere to this height, and it's going to strike into this one here, how high do you think this sphere will come out? If what goes in should be what we come out with, because equal and opposite reaction. So if my action is releasing the ball from here, where should my reaction on this side get me, do you think? What's that? You would think it should be about the same height, right? So watch as I raise it, it's about right here. So we would expect, based on what Charles said, that it should come out to about right here. Okay? Now, if I let this go, why is it gonna keep getting smaller and smaller of a height and then eventually stop hitting and moving altogether?
Air resistance.
There's going to be a little friction with air resistance. What else? Yeah, so some of that energy is transferred. That sound. Sound is a type of energy. Next unit is all about energy transfers. And so, so that energy isn't lost because there is something called the law of conservation of energy, but it does get transferred. So some of that's transferring into that sound. Right, so as every time you hear that click, that's a little bit of the motion or kinetic energy transferring into that sound energy. Right, so I'll do it again. You can see it pretty much goes at the same height. And what would happen, do you think, if I release 2 balls, 2 of those spheres? What's going to happen? How many should come out on the other side? Right, because what goes in has to come out. If for every action or 2 spheres, there should be an equal reaction. Okay. And again, the height that I dropped them from, so if I drop them from this far, those 2 should come out on the opposite side, just like Charles says, about that same height. Okay? And again, you hear the clicking, some of that motion, kinetic energy is transferred into sound. We have some of the friction or air resistance. There's also a little bit of friction between the string and the sphere where it's attached. So any place where things are touching, you're going to have a little of that friction, and so some of that kinetic will transfer into friction.
What if we take air resistance out of the equation? Would it go on forever almost?
If you could get rid of all of the energy transfers, yes, right? If you know, like I said, you hear that sound. If that sound can be removed and the air can be removed, we can remove everything that's working against the motion, then yes, you would think that it'd be like one of those perpetual motion kind of things where it would just continue on and on and on. Yeah, good thought. Okay, so what happens if I have 3 of them? There aren't 3 to come out on the other side. It's going to stay unbalanced.
It's unbalanced.
It is unbalanced, but the law of Newton's third law says that there has to be an equal reaction. So if my action is 3, how am I going to get 3 to come back out as the reaction? Any thoughts?
Higher.
Maybe they would just go higher, okay? Any other thoughts, Will?
The one is gonna keep going.
So the one in the middle might kind of just keep switching, okay? So, you see, I'll do it again. And even if I have, I can do it from this side, right? I could release, so if I release 3 from this side, then 3 are gonna have to come out, and so this middle one is gonna join with whatever the reaction side is. So here, my hand is holding the action side, the reaction side is hanging down. Until eventually, like, it slows and they all kind of get close enough where they're still just transferring, and now it's all just swaying together.
If you do 4.
If we do 4, let's try it. What do you think? I mean, we have action and reaction. Newton's law. Newton's law says that we should have, our action is 4, our reaction should be 4.
Instantaneous switching.
Whoa. Pretty crazy, huh? And what if I do at the same time?
Or just both go back.
Do you think that they would both just kick back?
What would happen if we slowed this down, like videoed it and slowed it down? We'd be able to analyze every reaction.
Well, I'm gonna post it in Google Classroom, so maybe you could try to do that with the video. See what happens. All right, so if I keep them even, and this one has gotten messed up a little bit, this string is a little bit shorter, so that's why it's not quite as smooth as it should be, but I will try to release them at the same time. The height look about even. So again, my string, actually I'm gonna do it this one, because this string is just, somebody got it tangled one time and I had to readjust it, so it's a little bit off. So I'm going to just hold this one out of the way and try to do it from the same height here. Pretty cool, huh? So what's going in has to come out. In and out, in and out. And so since there were 2 actions, there's gonna be 2 reactions. So in a way, it's kind of like, Anthony, I asked you not to have it like where you're using it. Thanks. Okay. Anything else you want to try? Sometimes you guys think of things that I haven't thought of or we haven't done yet. All of them?
Yeah.
Okay. So what's going to happen, do you think?
It's just gonna go back and forth.
Okay. So, right? Basically, 5 went in, 5 have to come out. Anything else? Yeah.
2 on both sides.
Ooh, let's try it. Hopefully mine is okay since this one on this side is a little short. Wait for that middle one to stop moving. Okay. What's your predictions? What do you think?
We're just gonna bounce off, both of them bounce off on each side.
Okay, so they're gonna hit and then just keep bouncing, and the middle one should stay pretty stationary. Okay. Again, like I said, it throws it off a little bit with this one string being just barely off. So pretty much. Okay. Anything else? What do you want to try, Dylan?
Just the middle one.
How am I gonna do that?
I don't know, but we need to find some way to do that. Because that would be pretty interesting if we were able to do that.
I don't know how we can do that. Any thoughts? No.
If you just hold the right 2 and then you get the middle one,
So hold these 2.
like hold them out of the way and then just get the middle one.
But then it becomes an outside one, or do you want me to do this middle one?
We're in a 3-dimensional space. What if we had it swing forward and 2 the other ways?
Well, it's not gonna work when things go this way because they're in line this way, yeah. Do 2? Like this? Okay. Now, what if we change the height? Kind of made me think about, what if I, have this one higher and then the one, on your right, not as high. So I'm holding them both. I'm gonna hold the one in my fist, I'm gonna keep out of the way. Ooh, 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 ooh. Let me try again. So if we go high and not as high. All right, so you should see the high come back out. Wherever you start high, it should go to the opposite. Okay, so I should see it go high on this side. So keep switching back and forth with the height. Uh-oh. Whew. That was close. Okay, any others that you want to try? What else you can think of? I think that covers them. Selena?
What if you have like a magnet and just put it on one of the sides?
Ooh, you know what? Let me see. I have a magnet here handy. I'm assuming that it's ferromagnetic. I'm not sure. We've never tried it. Let's see. Ooh, it is. So you want me to hold one out of the way? Okay, so if we hold this one out of the way, actually it's going to hold two of them. Okay, now what? Now just try doing it like we have been. Okay, so if I have this one out of the way, if I'm not within that magnetic field, right, it's not going to do anything. But if I move this a little closer, or maybe if this magnet was stronger, if I'm holding this one, maybe it'd be strong enough to pull that one. If I get too far away, right? So we're talking about adding in a couple different forces, right? When we add that magnetic component into it, it's keeping that out of the situation. Yeah.
So what if you hold both of the two outside ones out of the way, not like
Okay.
two outside ones, like both.
Oh,
And then you start swinging the middle one, and then you release the outside ones.
okay, so like this, and then release?
I was expecting them.
That's what you're expecting? It probably is gonna be different depending on when they hit in the swing cycle. Release them both at the same time or release one? Either way. Let's release one. Again, it gets a little, I might be due for a new cradle because they're getting a little wobbly. All right, try that one. Yeah, so it gets a little bit trickier, but if you can think the timing of it, like where it's gonna hit is gonna be the big difference here. Yeah, just kind of gets it all thrown off. But hopefully it lets you kind of see, you know, what goes in has to come out, and so kind of showing that, and that's why we call it Newton's cradle, because it goes with Newton's laws of motion. Now, if you have, obviously that's why, like when you take two of the spheres, you're doubling the mass, and so that's why you have to have double the mass come back out. So again, it comes back kind of indirectly to the idea of mass for all three of the laws. So just kind of keep that in mind too. All right, so